Hi there. I'm going to give you the summary of how we learned how to construct an angle bisector today. So I'm going to start by showing you this diagram that I constructed of an angle bisector. This red line here, see how it's going right down the center of this angle, right? So this angle that's formed by this line and this line, these two lines, is being bisected. It's cut into two congruent angles. We can even see that they're marked congruent here, two smaller congruent angles. Or as a review, a bisector cuts it in exactly in half. So if this, for instance, was a 60-degree angle, then each of these two angles here would be 30 degrees. But the angle bisector, the red line, is what we want to construct. And all this other bit here is sort of to give you an idea about what's special about angle bisectors, and then how do we construct them. Notice that this point, wherever I move it, is always the same distance from each of the two sides of the angle bisector. And we measure that distance along a perpendicular line. It's the direct shot at the line. Okay, so that's a really important thing about angle bisectors, is that the point is the same distance from this side as it is from this side. But then when it comes time to construct it, I want you to notice that there's some other things that are true. These 2 points, right, are the same distance from the vertex. In other words, this yellow segment here, it shows that this point is the same distance from the vertex of the angle as this point is. So we're going to use that when we make the construction. And then finally, see this purple segment here that connects those 2 points, right? That is perpendicular to the to the angle bisector, and it is bisected by the angle bisector. In other words, this segment and this segment are congruent. And so what that really means is if I can find these 2 points here, right, and I make a segment that connects them, if I make the perpendicular bisector of that segment, it's also going to bisect the angle. Okay, so we're going to cut the angle in half by first figuring out 2 points that are the same distance from the vertex, and then figuring out the perpendicular bisector of the segment that connects those 2 points. We're always aiming for the vertex, so keep that in mind. I've created an angle here. Okay, it's an acute angle, but this same process will work for an obtuse angle or a right angle, but let's just keep it acute for now. Remember, the first thing I want to do is find this point and this point that are the same distance from the vertex. So I'm going to use my circle tool. That's the first thing I'll do, is I'll take my circle tool, and since I'm aiming for the vertex of the angle, or point A in this case, I'm going to start with a circle from point A. Now, it doesn't matter how big or small this circle is. I can resize the circle later, right, by dragging point D around. But what matters is that these 2 points here are the same distance from the vertex. So again, those 2 points let's mark with the intersect tool. So I'm going to click on this line and then click the circle. See how it marked point F? And then I'll click on the circle and then this other line, and then it marked point H, right? Points F and H are equidistant from the vertex, just like this point was and this point was. So that's what I did. I used the circle to find those 2 points, okay? Now the next thing, and you don't actually have to make a segment, but it is helpful to see that you can connect point F to point H and make this segment here, right, that is purple in my other diagram. So let's just, let's make it purple so that it's a little bit easier to see. Okay, so we got that purple segment there. Okay, so what I want to do now to make it my angle bisector is I just want to make a perpendicular bisector of the purple segment. Okay, if I do, then it's going to go right through the center of that, but it's also going to go through the vertex of my angle and cut it in half. So now what I'm going to do is use my circle tool again, and I'm going to make the perpendicular bisector of this purple segment that goes from F to H. So I make overlapping circles. I go from F to H, and then I go from H back to F with my circles. Right, and notice that I have these 2 places where the circles intersect, and I can make it a little easier to see if I resize this. Well, anyway, that's fine. See how it goes? It'll go right through the vertex. So I'm going to use my line tool and connect those 2 intersecting spots. Well, it goes right through the vertex as well. And I've made an angle bisector. Let me take a moment and hide my circles so that it gets a little easier to see what's going on. Okay, and I'm also just going to make this easier to see. So what I can now see is that this line is going right through the center of that angle. Okay, and I can resize the angle and see how the line stays right through the center. And again, the key is this first circle is just to find point F and H that are the same distance from point A. Okay, so that's what we use that circle for. These other two circles are to construct the perpendicular bisector of segment FH. You don't actually need to draw FH. It's not necessary. You can just find the points and then make overlapping circles without it. So try the angle bisector investigation, and we're going to get into how to use those at our next class.